Today we will talk about how to build a simple CF recommender system. This is our outline. First, we will talk about the introduction, and next, we will talk the experimental and computational details. Finally, we will give you a conclusion. Nowadays, recommender system is increasingly popular. It can be implemented in any domain like movies, music, TV, and so on. For instance, when you go to some movie website to scan some movies, you may find that the website will recommend some movies which are marked with the guess you like. The kind of recommendation is graded according to the recommender system. The main purpose of recommender system is that offer some advice or information to users to help them finish their selection. In almost all recommender systems, the candidate items upon which computations are made sum from a single domain. Single domain means the system will only recommend some items which belong to one single. This paper is aimed to build a single domain recommender system to recommend some movies for users who use the video website. After building the recommender system, we will also evaluate the filtering degree of data which will be recommended to users to optimize the recommender system which will recommend some movies for users. In our details, we'll talk about the data cleaning, how to build recommender system, and how to evaluate recommender system. This part, we need to process the data which are gathered in advance. We collect the data which are movie rating from our classmates. Totally, there are 275 movies include the Excel. And we have the movies rating which is provided by 18 users. After collect the data, we need to clean them. Data cleaning process that reviews and verifies the data which are received by users. This is essential to process of data analysis. The quality of the data cleaning is directly related to model result. So the first step of building a recommender system is clean the data. This picture means the process of data cleaning. First, we need to processing. According to scan the data, we can get some basic information that a total of 275 movies are included in the Excel, and 18 users provide the ratings. Users' rating had been given on scale of 1 to 10, from I don't like it at all rating to I like it very much. NA represents no rating. After scanning the data, unfortunately, we found some missing data. Some people leave blank in the Excel. A missing value is the most common data problem. There are many ways to deal with the missing value. First, we are recalled to. After scanning the data, unfortunately, we found some missing data. Some people leave blank in the Excel. Missing value is the most common data problem. There are many ways to deal with the missing value. First, we are required to determine the scope of the missing value. Calculate the proportion of missing values for each flag, and then, according to the proportion and the importance of the flag, to select the different ways. It can be shown as the second picture. From the second picture, we can find the missing rate of the data is not high. Besides, because the amount of sample is accepted to be very big, the single movie's rate is not very important. Because of we choose remove this missing data, we will operate the step with the next step. As I said before, user rating had been given on the scale of 1 to 10. N-A represents no rating. However, someone used NA to instead of N-A. In order to ensure the consistency of the data, we use N-A to instead of NA, like the second picture. And next, we use 0 to instead of N-A and the missing data, which I said before, because change it can be easily for us to build a recommender system. In this part, we need to solve the problem that we have some repetitive movies, like final distinction file. We want to calculate the average value of repetitive movies and then delete them. If someone is the repetitive movies rating just one time, we will record the rating which he gives and do not calculate the average. Next, in this part, we want to delete the data which is needless. What means the simplest explanation is that the data which will not affect the result. At the same time, if we delete them, the complexity of the algorithm will reduce. At that time, data can be named needless data and we can delete them. From our data, it is not hard to find that some movies does not have any rating. That means everyone feels NA in this movie. This kind of movie cannot help us to build a better recommendation system, so we can delete them.
I want to introduce how to build a recommendation system to analyze the algorithm. I use SVD, which means singular value decomposition. I found it from the article. If you like this, you are sure to love it. And I find SVD may be a good way to build the recommender system. Introducing the singular value decomposition, I want to introduce the eigenvalue decomposition. Suppose the vector V is the eigenvector of matrix A. It can be written as A multiply vector V equals lambda multiply vector V. So lambda can be called as lambda eigenvector V composed the eigenvalue, and the eigenvalue decomposition can be a matrix decomposition form as A equals Q lambda Q multiply lambda multiply Q transpose. The key is form the matrix by a matrix as eigenvector, and the eigenvector can rotate the vector V like these two C's rotated, and the eigenvalue can stretch the matrix. So come back to the singular value. The singular value decomposition can be shown as these three matrices, and after that, we want to know more about the lambda size. In the lambda matrix, it is from the biggest to the smallest. The decrease of lambda becomes very quick in the most situation. The 10% hand of lambda, even 1% of lambda, sum is takes 99% of the whole lambda. So we can use R by R. The small lambda can similarly describe the matrix A, and which can be used for the movie rank. I use scripts express linear algebra package, and there is a singular value decomposition package, and I use it to matrix decomposition. Use this package to get how to decompose the matrix AS or the user ranking, and I make the R is the matrix size. Like I just use the original size, and this in this function it makes the R as 6, and here is the result. I print it out, and after that we will get this as the user rank. Suppose they watch there are 18 person and 250 262 movies, and suppose they watched all the movies, and here are the results of some results of the matrix standard matrix using standard deviation. And after that, I use each user's average rank, like multiply the all the ranks in the different movies, and grade the rank above the average. Want to use machine learning tools, I can just write the rule here, and to test all possible and just to evaluate the similarity between the original rank matrix A and the X predicts. But I haven't do it because I try to make the R the number R inside, but I do not what inside of this SVD package. Get each user's average rank, and regards the rank above the average is positive, below the average is negative, and I need to recommend this unranked movies to that user, so I need to get the positive movies and with unranked movies. I finished my part, and the next part is about Yuwei's evaluating recommender system.
Okay, thanks Lydia for introducing the algorithm of SVD. And now I will introduce you the way of evaluating the movie recommender systems. As for evaluate the movie recommender system, the most important part is to measure the accuracy of a recommender systems. So our group used a math method called MAE, which is a shortcut of mean absolute error to calculate the accuracy of our recommender system. And here is the formula. So what is the meaning of this formula? We can see that in this case, this is the table of the predict rank and the actual rank of one user, and here are the 4 movies, and this is the rank of the user predicted by the system, and this is the actual rank of the user. So in this formula, Fi means the value of predict rank, Yi means the value of actual rank, and N here means the total number of the predict data of predict rank and the actual rank. So the aim of this formula is to get the result of subtraction of the predict one and the actual one, and then calculate the mean, so that the smaller the value of MAE is, the more accuracy the result is. So which means the differences of the predict one and actual one is small. Like this example in this table, the MAE is the paired number is 4, and the 10, 4, 7, 9 is the predict rank, and the 8 something is the actual rank, and we absolute the the the, the differences and then calculate the mean, which is 1.5. So by knowing this principle of the function, how to achieve it in Python code? Like this, after the formal parts like Lydia did, and we got the two tables, which are the actual rank and the predict rank. The actual rank we can get from our student rank. Like this is the line of movies, and here are the lines of users, and this one also, so that we can get the two tables paired with each other. So our goal is to import the data to these two tables and then get the result in Python. We can see that all the values are paired with each other, and this is the user one for the first movie, and this is also the user one for the movies for the actual and the predict rank. So now this part is to achieve it in Python code. The first part is to import the two Excel tables. I named it like the movie actual rank and the movie predict rank. And the second part is to create a new table of subtraction. This is I minus them and then outputs it in a new array. And the third part is achieve the formula in code. This is the math formula. So after we run the Python code, we could get the value of MAE. This is the printout. And this array is the array of the -1. And here is the MAE result, which is 1.57879 and something. So we could see that there is a little distance between our result and 0. So that may be because of the algorithm of our recommender system is not accuracy enough. Or maybe the amount of our data is not big enough. And these are all the reasons that we could cause the problem. So that we need to find out more ways to handle the recommender systems. So now welcome Lydia to introduce more about our result and our future plan.
Finally, I want to talk about the results and the discussion parts. We want to do a segment analyze in recommendation system. We will collect that the information from these review sites, blogs, news, and the micro blogs. So we need to use the text analyze. And in order to do the text analyze, we need to use natural language processing. We find a Python package called NLTK to make the sentence analyze. The first step is to need to tag the text like I can make these reviews as positive and negative parts, and we can make some part of the reviews like the human tag, and then make the reviews, the positive reviews and the negative reviews the same amounts, and then I need to choose the features. Features is objects features. Objects shows features is base of the classification, and after that we can use the NLTK package to deal with it. Using the package, we will get the total number of the word appearance and the ratio. We can use this data to get the total emotion of the movie, and we need to collect each user's attitude to each movie, and we can rank it and connect to the projects we have done to make a simple CF based on SVD. We can use the SVD to optimize these ranks and get the final recommender. That's all. Thank you.